Alrighty, let's walk into our problem 5 of exam 1 walkthrough. And today we are going to be looking and examining this problem. So let's let f of x equal to x squared minus 4 and g of x is equal to root x plus 4. For a and b, construct a function and state the domain of part a and c. So you have two directives here. But let's start with a, which is g of f of x. So the way that we look at this type of problem is g of x. And we basically plug in our function f, or function f of x, into g of x. And I kind of write that in different notation here. So g of f of x. If we had a value, we would do f of x first and then plug it into g after that. So obviously it's root x squared minus 4 plus 4. And in this situation, basically, we just plugged in our function of f of x into g of x. So our function f of x is in a parentheses there is x squared minus 4. And now we just simplify through the whole problem to get our value. So we see that we have 4 and minus 4, so those just cancel out, and we get root x squared. And we can use the rule of root over x squared, it cancels out. And we'll explain that rule a little bit later too in one of our other problems. And then the way this affects domain, since we get rid of the radical, we actually have a negative infinity and positive infinity. But I'll go into writing too to explain what's going on, and I'll write a couple keys too to explain for you. So let's take a look at that, and I'll come back when that's done. Again, negative infinity and positive infinity. I'm just notating the rules that we use to follow radical restrictions. And it shouldn't be root can't equal 0. Actually, a root can't equal a negative. Root can equal a 0. We will end up with an imaginary number if we put it into the negative slot, or negative into a even root. So that restriction applies to even roots, not so much odd roots, because we can take odd values of negative values. Let's get into problem number 2 now, or B, excuse me. We're going to evaluate f of g of 3. So like I was talking about before, I'll just focus on g of 3 to start with, but I write it in the notation of f of g of 3, and then I just plug in the 3 into the g equation first to make it a lot simpler and not have it so much information going on. I mess up here, but make sure you always write your value here as g of 3 equals. So always put your function equals, right? Just don't start off with what you're doing. So you'll see me make that mistake and then fix it here in a minute. and then we do 3 plus 4 because we're plugging in 3. You should add a parentheses here, but I did not, and we get root 7. Now that we got root 7 from that, we can plug that value into f of x, so it should be f of root 7, and then we can simplify further in there. And I write this out for you. And now we just simplify here, right? So we have root 7 root, so that takes care of that root. And then we just do minus 4, and we get 3. So f of g of 3 will equal 3. Kind of explain that rule a little bit more. Remember, if we have a root over something squared, we can take that out, or if we have a root squared, those two cancel out. Everything has to be under the radical though, make sure. And then for this other example where we're going to have something squared and we take the square root of it, make sure everything is getting everything is either taking the root taken of or is squared, and we can cancel out all those. We just can't make up our own rules. So that's the end of that problem. Let's talk about C. Right off the bat, we see a fraction, and we know that our g function has a restriction itself, and you'll see me explain both of those here. So we cannot have the bottom equal to 0, and the top has to be equal or greater to 0. And we notate both of those. So we have two restrictions here. We have a denominator restriction and a radical restriction, with the radicand having to be greater or equal to 0, and the denominator cannot equal 0. So I'll represent both those equations and solve accordingly, and we should get our restrictions there. I'll come back to you and talk to you after that is done. Our first part, obviously our restriction comes down to x has to be greater than or equal to 4. And this next part, we're solving for what x cannot equal to. And remember, we have to take the absolute value, so we'll end up with 2 terms here, or plus or minus 2 after we take the square root of 4. And you see us notate that. And you see us go into detail about having to split both those values up. So we'll have a clean, which would just be x equal to 2. And then if we did the dirty, we'd have to distribute a negative to both sides. So we should have x minus 2, because we just have to subtract the 2. We should actually add a 2 and then divide by negative, which is how we get the negative 2. And that's the dirty. And then we're going to put this on a number line, which really helps us visualize the domain. It's very important. In this next part, you're going to see me make a mistake of just doing our negative 2 and 2 value and work through that, and then I'm going to check the problem because I know something's not right. I want to highlight this part because this is super important for these types of problems. Take your time and know all your restrictions. You're going to see me mess up here, and you're going to see me reevaluate it, and you're going to see me come out with the correct answer because I did know something was off. I did feel something was wrong. There's been multiple times I've been on a problem and I knew something fell off, so I redid my work, and then it ended up working out in my favor. So you see me make the mistake, and then I'll come back and explain the correct answer after I notice that I made the mistake. right here I'm checking my work and I'm trying to visualize what I'm missing because I know something's off. Looking at the entire problem. Boom, forgot my first restriction. So we notate that and we redraw it. Very important that we take our time to look at our mistakes like that and to reanalyze our problem. So now we can start with our lowest value, straighten up our line a little bit, and we get -4. This would be including, because of its restriction guidelines, we are looking to over this value and including this value. So that would be a circle or a full circle. And then we have -2 and 2, both being a restriction that we cannot equal to, so we'll represent those as circles, open circles, excuse me. You don't have to draw the curvy lines through -2 and 2 because we do not include those values, but it's important to notate because it helps me visualize my domain a little bit more, and I know I'm not including those values, so I'll purposely exclude that out of my domain. So we include -4 to -2 will be our first point where we have to stop. So our first part would be including -4, -2, union to the next part. And our next part that we have to include, because the values inside might work as well, we have to do -2 to 2, not including, to show that -2 and 2 do not work, but maybe -2.5, 0, or 1 do. So we have -4, include, -2, don't include, union, -2 to 2, include, and then we pick off right again at 2 after our union sign to infinity. And that's our answer. Thank you for reviewing this with me. I appreciate your time, and I hope you have a great rest of your day.